So 3B.7, sinusoidal function, context, and data modeling. So in our previous units, we looked at different methods to construct models of various functions, right? How to make an exponential function, how to make a rational function, how to decide if log or is the better model, right? However, we are now in our trig unit. And so we've seen that sinusoidal functions can be written in the form of, it got a little weird in my notes, but or not. You know, I didn't want to write anyway. Okay, there we go. F of theta equals your A, and your A is called your what? A represents our what? Amplitude. The A represents our amplitude. Sine. Your B has to be factored out. So your B, and B represents our what? It's part of the period. Theta plus C, and C is our what?
Oh, no, that's like the translation.
It's our phase shift. Okay, it's our translation, our horizontal translation, plus D, and D represents our what? Our midline. D represents our midline. Okay, so everything has a place, a responsibility, correct? And these same things apply to cosine. Okay, remember, depending on your interval that you're looking at, your phase shift, you could either be analyzing a sine or a cosine from the same graph, right? Just depends on where we start. Okay, so that's what, huh? Oh. So let's look here at the sinusoidal function. Most of these problems will be multiple choice. So what we're practicing and emphasizing on is how to work these problems as multiple choice. They will be non-calculator multiple choice problems. Does that make sense? So as I was saying before, your assignment for 3B.7 is multiple choice practice problems. Okay. I know we don't get a lot of multiple choice homework, but it is multiple choice. Once I finish it, it will be on your Canvas for you to go through and answer. Okay. The beauty about this is that right away you'll know if you got it right or wrong, right? And you will have multiple attempts to try to get the highest grade possible, right? But the key thing here is if we do well on our multiple choice, which is almost 60% of our tests, right? If we do well on almost 60% of our tests, our FRQs, you know, we have a little bit of a breathing room, correct? Make sense? Okay. All right. So up first here, we have f is a sinusoidal function and is given in the xy plane and is simply just asking, what is the period of f? You're geniuses. How'd you know that? You can just count. Okay. One, identify where your midline is. So my midline here is at -2. And it starts and stops here at 0. So therefore it is a 2-unit period. Yes? Agree? Yes. Yeah. On the non-calculator. What's the period?
Wait, Kim, is that going to be a question on the test on Monday?
Okay. Yeah. All right, let's get up a little notch. Here, it says, let G be a sinusoidal function. G of x equals cosine 2 of x plus c minus 1. The graph of y of g of x is given in the xy plane. Which of the following value could represent the constant c? Meaning, what is my phase shift? Which value could represent my phase shift? Okay, so the first thing you want to acknowledge is that cosine is positive, right? So we're looking for when can we make a cosine graph? A positive cosine. So where can I make a positive cosine graph at?
Oh, the pi, at the pi 2, not C.
Good job, Randy. So this is one positive cosine, right? And then this is the start of another. So therefore, I meant to do it in 2 different colors. Don't know. And here is the start of another. Does that make sense? So when I'm looking for my phase shift, it's the start of the pattern. So I either can be at negative pi over 2 or I can be at positive pi over 2. Does that make sense? So the only option here that we can see is C. And that's because it was a positive cosine. Majority. A negative cosine? An upside down cone? If it was a negative cosine, it wouldn't be a phase shift because it would be at 0. Do you see that? So I wouldn't have to shift left or right. No, it would be a negative cosine. So if love this question. Good job, guys. So if it was a negative cosine, my phase shift would be 0 because the pattern starts at 0. And that's when it would be a negative. So it would be written as I'm going to call it f of x. F of x equals negative cosine. And it's just 2x minus 1. Because I'm starting at 0. And there's no reason to write plus or minus 0. Yes?
Wait, you understand? Oh, when did you say the next 10?
Monday.
Monday,
Okay.
3:31.
What's it on?
It's over 2B.
What application is it gonna do?
Oh, AP class.
Oh, why did you spending RD the fourth quarter? Oh, nice. Can we not take a camera study?
Why can't we?
We always take a test on the camera.
Why can't we do it? You just took one over Canvas. AP classroom.
No.
No. All right. What was your question? I'm sorry. They are the same. You can create multiple sinusoidal functions from one graph. What matters is your phase shift. So your amp, your period, and your midline are going to always be the same. What changes is your phase shift. So where you're analyzing it from, where the starting of it is. And you can turn it into a sine function. If I made this a sine function, let's say I made it a sine function starting here at negative 1/4, negative pi over 4, right? Then it would be from here to here to here, right? No, it's sinusoidal, so it only toggles between sine and cosine. All right, let's try a harder one. Okay, I want you to take a moment, read through this at your table, determine which sinusoidal function best models the situation. So this time you have to create the model. Problem. All right, so the first thing first is finding the period. The reason why we find the period first is because then we can find our B value. Does that make sense? So finding the period, right, P equals, it is 5 seconds, and you get 20 rotations, which means your period is 1/4 seconds per rotation. Does that make sense? Okay, so then therefore to find my B, remember period equals 2 pi divided by B, right? So I have 1/4 equals 2 pi divided by B. What is my B? Cross multiply. 1 times B is? B would be 8 pi. And which one has your B as 8 pi?
D.
D. Me. Nice try. They're not even that long.
Wait, what are we doing after this?
Oh, I'm not repeating myself. Yeah. Thursday.
You were using the restroom?
All right, here we go. So next, modeling data from information. We have a clock is mounted on the wall, and the point P is located at the tip of the minute hand of the clock. The function h represents the height of the point P from the ground at time t, where h of t equals the sine function model. If h of 0 is 70 and h of 30 is 52, represent a maximum value and a minimum value, respectively, on the graph of h. What are the values of A and D? So A and D means we're looking for the what? A is our what? Our amplitude. And D is our midline. So first we're going to do our A, which equals our amplitude. Okay. If we remember how to find amplitude, remember amplitude is just the, no, your amplitude is just the
Basically the midway point between
the distance from the midline to your max or min, right? So your amplitude equals your, let's just say your max minus your midline. So in order to find my amplitude, I need to find my what? Well, we know our max, guys. It says it. We need to find our midline, which is our D. D equals our midline. Your midline equals just the average between your max and your min. Average between max and min. Do we know how to find the max between 2 points? The average between 2 points? Yes. I would hope so at this point. So D equals 70 plus 52 divided by 2.
That would equal 61.
And that equals 61 because it's 122 divided by 2, which is 61. So now I know the value of D. Can I now solve for A? Yes. What is my max value? 70. What is my midline? 61. So what is A? A equals 9.
Good job.
Again, this is simple math. It's knowing what you're doing that makes it, I guess, a little challenging. I said knowing what you're doing is what makes it a little challenging. Sometimes you guys don't.
You can make a note card, right?
Yes. All right. Questions about being able to find D and A from here. Okay. Oh, quick question before I move on. What if you needed to find your B? B is 2 pi over B. So, but if I only have the max and the min, that's only telling me what about my period? It's half. So if they give me my max and my min point, that's only half of my period. So it just reiterating here, I know this is not what the problem's asking us, but I wanted to make sure. Your period is based off of the change in your domain, the change in your x values. So my period, this is only half of a period. So half of a period is 30. So what would be a full period?
60.
60. So the period equals 60. And that's because this is only, when I have the max and the min, that's only half of my period. Does that make sense? Okay, so then the full period is 60. So to find my B, I would set this equal to
Pi over.
2 pi over B, and then I could solve for B. Does that make sense? Okay. So I just want to let you know, if they ask you additionally for B, could you find B? Yes. And it would be what? What would be? What would it be? 2 pi over 60, which reduces to what? 1 pi over 30. All right. Let's keep talking about max and mins. So here it says the average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by the sinusoidal function T of M equals 24 and 7/10 sine pi over 6 times m minus 4 plus 61 and 2/10. M is between 1 and 12 because that represents the months of the year. Based on the model, which of the following is true? So it's asking what is true. Obviously, it's talking about maximum and minimum. So if it's talking about max and min, then we need to figure out those values, right?
Plus or minus 61, or 61.2 plus or minus 25.7.
Well, you need to figure out where they are.
Well, 61.2 is midline. The amplitude is 25.7.
And what do you get? And so when you're looking here, which answer would it be? The average, it would be C. Good job. As I told you, they were short notes. You're gonna work on the assignment as soon as your teacher is done over here. Yes.
So the B was 5/30. Would you plug that in? 5.
It would just be pi over 30. Yes.
And I'll just compute that.
Yeah, no. If they ask for your B, it would just be pi over 30.
That's makes it.
It would be B pi over 30. Yeah. All right, so do we want to see this worked out, or we understood what August said?
Yeah, it is. It worked out. Yeah, right. Yeah,
Mhm. Minus 25.7 gives you, and that gives you your minimum. Yeah? Okay. So because we have our midline and we have our amp, we know that our average had to be the difference between those two. Does that make sense? And that's how we end up with 35.5 as being the true statement.
If we put that for M,
Um,
letter C.
no, it's just asking based on this model, what is true? What can you assume about the graph? Yeah.
So what number you put in for M? The number of months.
M would be like if you were on a month. So like if you're on January, then you would plug in 1, and that would be the average. If you were on 12, that means you're in December, you plug it in and evaluate. But it says minimum average monthly temperature is 35.5. And the reason why we say that is because how so let's just look at January. So T of 1 max equals, so we're going to plug it in, sine of pi over 6 times 1 minus 4 plus, I'm squeezing it in there, 61.2, right? And when I evaluate that, I end up with this equals 25.7 times negative 1 plus 61.5. 0.2, not 5. Don't know why I wrote a 5. So when he said all you have to do is find the distance, it's because mathematically when I plug in the 1, I'm just going to come down to 61.2 plus a negative 25.7, which is just simply doing what? Subtracting, right? And so then that leaves us with the 35.5. Huh? I don't know. I'll have to look to see what you put in. Last one is analyzing from a table. Looking at this table, it says the function n gives the number of nighttime hours on the first day of a given month, where t is between 1 and 12. The table gives values of n at selected values of t. Sinusoidal regression model with 16 iterations is used to model this data. What is the maximum number hours predicted by a sinusoidal function model to the nearest hour? Okay. So here, in order to find this, you would have to find your A and your D. Does that make sense? So in order, we would have to find our A and our D. Your D is your midline, which is the average between your max and your min. So first I'm going to identify what is my max here. My max is roughly 11.4. And what is my min here? 5. Agreed? So therefore D, my midline, equals 11.4 plus 5 divided by 2, which is it? Yeah. Okay. So that's our midline. And then to find what is the maximum number of nighttime hours predicted by a sinusoidal function, our A would be what would our A be?
Would be our amp. It would be.
Mm-hmm.
3.2.
3.2. So based on our model here, it would be closer to 11.
You subtract.
You subtract.
The maximum.
Your A comes from subtracting your max and your midline, which is about
Okay.
3.2. So see how close that was? Like some people said 12 off the bat, but until you do the actual math, it actually came out to be what? 11. So be careful, double check yourself. But the main thing is that you understand what you're looking for. Okay.
Oh, so add them up, it's 11.
Exactly. And 11.4 rounds to 11, not 12. Right?
Got it.
Yes.
So why can't we take a little bit of max? That's what I was doing. Yeah, it's closer to 11 than it is to 12.
I think because these numbers were so close,
Yeah.
that's why. But if the numbers had been different, like not as friendly, what if they were larger numbers or there was more numbers, then you would have to identify. So I'd rather show you like the math behind it than us just saying, oh, this is the value. Yeah. Oh my gosh.